The next section is about comparing two means, and we're going to start by doing a two-sample t interval. So as you can see, we have the formula in front of us. We are going to start, our point estimate is going to be the difference between two sample means. Then we're going to do plus or minus our t star, our critical value. So underneath that square root, just to note that this thing right here, this is actually the same as S1 over the square root of N1, the whole thing squared. So that's where that came from. If you remember that actually was part of our regular one sample t interval. So for this formula, by the way, just a reminder that whenever you are doing something with a t, you are going to need a degrees of freedom. So for your degrees of freedom, you are going to use whichever of n1 minus 1 or n2 minus 1 is smaller. And the other option, which I think most of you are going to just use your calculator. So, or you can just use your calculator. And I do want to emphasize that either way that you do it, make sure you write down what degrees of freedom that you use. That's going to be very important for anything where you involve a t. Okay, so the other thing is that in this case, our conditions, as you might be able to guess, they are the same as a one sample t interval. The only difference is that we're doing it for both samples. Okay, so let's go ahead and do an example. So for the next example, we have two girls who want to see if generic chocolate chips have the same amount as name brand chocolate chips. So they are going to select two random samples of the different types of cookies, and they check the number of chocolate chips. So we're going to start by doing a 99% confidence interval. I'm actually going to show you how to do it by hand, but you are welcome to try it on your calculator in addition to it. If you're not sure how to actually do it on the calculator, I'll show you next time we have class. So the first thing that I'm going to do is I'm going to kind of organize my data. So I'm going to start with my Chips Ahoy. You are welcome to call that 1, or you can call it like X with a subscript of C. I'm going to just call this one X bar of Chips Ahoy, and then you can do the same with all of your other things. Sometimes it's easier if you're going to do something by hand to use these. However, if you were to do this on your calculator, you probably are going to want to use 1 and 2. So it's up to you. So then for these, you need to actually find these out by putting one of these into L1 and put the other into L2. So that's the first thing that you need to do. And actually, if you do it on your calculator, you might find that you can just put them into L1 and L2, and then you can just directly do the intervals without having to do a lot of extra work, which is really nice. So you're welcome to try that. So anyway, when I went ahead and put them in, I'll give you the statistics that I found for both of them. So you'll notice that in addition to I ran one variable statistics on the calculator, I also found histograms. You must show a sketch of your histogram whenever you're doing a t-test and you have samples of less than 30. In this case, you do have to do both of those. So the other thing that's very important is you also must mention how many degrees of freedom. And you're going to do 10 minus 1 equals 9. So this is just writing out the data. Now I actually have to do the whole process. I have to check my conditions. I have to name the interval that I'm going to do. If you want to do it on your calculator, you can. I'll show it by hand, though. Okay, so I wrote my conditions out. Make sure that you have 2 independent random samples. 10 is less than 10% of each cookie type. You have to check those separately, especially if your sample size is different. Also, you must write down that the distribution is not skewed, has no major outliers, and you need to draw that. I think I mentioned that already, but just want to emphasize that. The other thing is you need to mention that we are going to use a 1 sample t interval. So let's go ahead. We're going to work it out by hand. If you would like to skip this part and just do it on the calculator, I don't see any problems with that. The one thing I am going to tell you is that I noticed on mine that the great value has a higher mean than the Chips Ahoy. So I'm actually going to use my great value as my first one, even though it's the second one listed here. The reason I'm going to use as my first one is because it is a higher value, and so when I do it, it's more likely to give me positive numbers. However, I might get negatives in the end, and you'll see when that happens. So let's go ahead and do this. So this is the formula that I'm going to use. I'm not going to show you all of the steps. I will tell you that my T star is 3.25. You have to find that using the table, or I think, as I said before, if you do everything on the calculator, the T will be listed there. It should be listed at least. So in the end, when you do this, you end up getting 1 plus or minus 4.122, which gives you negative 3.122 to positive 5.122. I just want to warn you now that it is possible that you have negatives and positives. Don't be alarmed if that happens. The thing to always look for on these is look and see if 0 is in the interval. So we're gonna talk about that in just a minute. So let's go ahead, write our conclusion, and finish it up. So here's my conclusion. You would say we're 99% confident that the true mean difference in number of chips and great value in Chips Ahoy is between negative 3.122 and 5.122. The one other thing I want to mention is if you do it on the calculator, make sure that I would honestly just copy all the information that you get on the screen. Just copy it all down. It'll give you a bunch of stuff. Just write everything down. That way you can prevent missing something. And the one thing I'm going to say is if you do it on the calculator, make sure you write the degrees of freedom. Because actually, your calculator is going to give you something slightly different for the degrees of freedom than what we got. It finds an exact value, and we're just kind of estimating it. So, so just write that down. Okay, so the last question they ask is, does your interval provide convincing evidence that there is a difference in the mean number of chocolate chips? And what you're going to always look for if you are working with anything with 2 samples is you are going to look for 0. See if 0 is in the interval or out of the interval. And in this case, it is in the interval. There's negatives and positives. So we're going to say since 0 is in the interval, we have no evidence of a difference.